What's up, Geometry? Thanks for tuning in for another episode of Math with Mullins. Today we're going to look at lesson 4.6, Symmetry. So we'll be able to use the line of symmetry to determine if the reflection carries a figure onto itself, and also use rotational symmetry to describe rotations that can carry a figure onto itself. First off, we have some definitions for our vocabulary section. So symmetry is a rigid motion that maps the figure onto itself either by translate, rotate, or reflect. Okay. With line symmetry, that is, each half of the figure matches the other side exactly. And we'll again show some pictures of that here in a second. And then the line of symmetry is when a figure is mapped onto itself by a reflection in a line. So, examples of symmetry. For this one, I just drew the letter H. And it's not going to be perfect, but you get the idea. Symmetry would just show a rigid motion that maps a figure onto itself. In this case, we're going to see a reflection because the left side can be reflected to the right side. Okay. Line symmetry, that is showing each half of the figure matches the other side exactly. For this one, I drew a trapezoid. Again, trying to draw on this is tricky, but here would be line symmetry. So the trapezoid has one line symmetry. And then line of symmetry is when a figure can be mapped onto itself by a reflection in a line. So this could technically be the line of symmetry because both halves reflected onto itself would match. Okay, what we're going to do now is determine whether each figure here has a line of symmetry, and if so, draw the lines of symmetry and state how many lines it has. So in letter A, one easy way to do this is to be able to rotate your paper. So we would first say that yes, this figure does in fact have line symmetry, and we're going to do all those lines now. Here would be one line of symmetry, and then what I did is I rotated my paper to show all the vertices first. So from here to here, this would be 2, 3, 4, and then 5. Okay, so all of those are going to be 5 lines of symmetry. For letter B, there are no lines of symmetry. And then letter C also does not have any lines of symmetry. However, letter D does. And this one, again, we can go from vertex to vertex. So here could be 1, 2, and 3. But then we can also go in between each one and say 4, 5, and 6. Again, my lines are not perfect, but you get the idea. It's a little bit easier to draw that on your paper. Okay, I wanted to point out something too. In letter A, this is a pentagon. And notice that there are 5 lines of symmetry, a regular pentagon. And then number 6, or letter D, is a hexagon. And that one is showing 6 lines of symmetry. So maybe think about how that's relating to some patterns you might notice. The next thing we're going to look at are a few more definitions. So now we're going to get into rotational symmetry, point of symmetry, and then magnitude. So rotational symmetry, another word for this, you can name it radial symmetry. And that just means if the figure can be mapped onto itself by being rotated less than 360 degrees about the center of the figure. So obviously a rotation of 360 degrees is going to make it look identical, but we want to know, could that figure show 360, less than 360 degrees to make it the rotational symmetry. Point symmetry states if the figure can be mapped onto itself by a rotation of 180 degrees. So we'll look at some of those. The point of symmetry is the center of symmetry in the figure. And then the magnitude of symmetry is our angle of rotation, which is the smallest angle through which a figure can be rotated so it maps onto itself. We're also going to talk about one more thing that's not here on your paper, and I'm going to add it over here, and that is order. The order is the number of times a figure can map onto itself. And we'll talk about that too in the next examples. Okay, so rotational symmetry, if the figure can be mapped onto itself by being rotated less than 360 degrees, I'm going to draw a diamond here. I'm also going to show the point of that. This diamond can be rotated 90, 180, and 270 degrees, and it still would repeat the same image. Point symmetry is just 180 degrees, so if we think about a rectangle, if I flip it upside down, it would still be the same thing. And then point of symmetry would just be the point in the middle of that figure. So if I had this rectangle and I made that point be where I'm holding it down and rotated everything else around it, magnitude is just going to tell me at what is the smallest angle. So I'm going to go back to the diamond. The smallest angle for the diamond would be 90 degrees because I can rotate it 90 degrees and it would map onto itself. Okay, so what we're going to do now is try our last little bit of questions and determine whether each figure has rotational symmetry. If so, locate the center of symmetry and state the order and magnitude of it. So in this case, we already saw that this has line symmetry, but we can also say yes, it also has rotational symmetry. The order in which it can do that, so again, order is the number of times a figure can map onto itself, and that is usually the number of times that you can rotate it before you get back to the start. So if this is where you start, you can rotate it 5 times and it would come up to be the same image. The magnitude is easy to find if you take 360 and divide it by the order. So in here, we would take 360 and divide it by 5, and that's going to give us 72 degrees. This is just showing us the degrees to rotate where the figure will look the same. So if you have your paper in front of you, if you rotate your paper 72 degrees, which is almost 90 degrees, the pentagon will look the same, okay? The center of symmetry is going to be right there in the middle of your figure. I'm recording a video.
I told Izzy that she can come pick this up from you because I'm going to be on the call.
Sounds good. You leave it there. The next one is rotational symmetry for a trapezoid. And what we're going to see here is this one does not have any rotational symmetry because it only has one order. And that means I have to spin it around. I can only spin it around one time for it to look the same. So that magnitude is actually going to be 360. Sometimes you can find the magnitude first and then the order. So if I spin this 360 degrees, that's the only time that it'll be identical. So that's why we only have one there. For this guy, we do have rotational symmetry. There is 2 orders for this one. And the reason is because our magnitude is going to be 180. So if you think about how do I get 180, I split 360 in half. So right here is telling me my order so that I can get my 180 degrees magnitude. And then letter D, this one also has rotational symmetry. If you rotate this figure 6 times, if you look at your paper and start rotating it 6 times. So 1, 2, 3, 4, 5, 6. That is the number of times you can rotate it so that it can look identical. So my magnitude, I would just be taking 360 divided by 6. That means for every 60 degrees I rotate this figure, it will come up looking the same. Okay? That is going to conclude our notes today on 4.6 symmetry. Hopefully that helped you decide what they look like, how to find the order, how to find the magnitude, and next time when we tune in, we'll be getting ready for our chapter 4 test already. Have a great day, geometry, and we'll catch you next time. Bye.